Hey everyone, my name is Matt Bogaard from Keith Gido's Fish Ecology Lab over at Kansas State University. I'll be speaking today about our research where we're assessing capture and translocation to improve spawning migration connectivity of razorback suckers in the San Juan River. I'd like to start off by thanking my collaborators, many of whom are already co-authors on this research, but I'd like to specifically thank the San Juan River Basin Recovery Implementation Program and the U.S. Bureau of Reclamation for funding this work. So despite several years of hatchery augmentation and other management efforts such as non-native fish control and floodplain management, there's still virtually no detected natural recruitment of razorback suckers in the upper Colorado River Basin. Barriers throughout the basin limit movements between spawning habitats, thereby limiting overall reproductive potential and hindering species recovery goals. Throughout the basin, the construction of fish bypass channels are seen as valuable tools to improve connectivity between those habitats. However, it's often desirable to limit that to selective passage where managers might seek to limit the dispersal of non-native fish while allowing native species such as razorback suckers to move into upstream habitats. Beginning in 2016, a concerted effort began to provide selective passage for razorback suckers at a waterfall barrier in the San Juan River. This consisted of a capture and translocation strategy where fish are physically captured below the waterfall and then translocated into upstream habitats. Earlier assessments into these efforts relied on physical recaptures of fish as well as acoustic telemetry to provide these upstream detections, which are displayed in the figure here. Although only a few of these upstream detections were made, they did provide some course movement data for these fish, and we were able to observe several long distance movements following translocation. However, it was unclear how razorback suckers were using specific habitats following translocation. And that research did indicate that more than 80% of translocated razorback suckers were moving downstream, once again below the barrier following translocation. However, it was unclear when that downstream movement was taking place. So while that earlier research was important in providing information about the movement ecology of razorback suckers, it left us with several outstanding questions. Primarily, we wanted to address how long translocated fish were remaining upstream of the barrier. And secondly, we wanted to know if these translocated razorback suckers were continuing their upstream movements where they could be detected into these putative spawning aggregations. To address these goals, we're looking at the San Juan River, one of the larger tributaries to the Colorado River, pictured here, flowing southwest from the San Juan Mountains to its former confluence with the Colorado River, now inundated by Lake Powell. Although there are several barriers to fish movements within the San Juan River, we're going to focus on two specific barriers, beginning with the Paiute Farms waterfall pictured in the bottom left. The waterfall was formed approximately 30 kilometers upstream of the San Juan River inflow to Lake Powell. This formed as a result of the declining reservoir levels, leaving behind massive sediment deposits. As the river corridor returned, it abandoned its historic bed to where it now flows over a 25-foot bedrock outcropping. Since 2001, this 25-foot waterfall has formed a complete barrier to upstream fish movements for two of our endangered species, the Colorado pike minnow and the razorback sucker, as well as limiting the upstream dispersal of non-native predator species that persist within Lake Powell, such as walleye and striped bass. The next barrier we'll look at is about 270 kilometers upstream. That's the Public Service Company of New Mexico, or the PNM Weir. This is a river-wide low-head dam which serves to divert water to a nearby Four Corners power plant. To mitigate the adverse effects of this barrier, a fish bypass channel was completed in 2003. The bypass channel does include a fish trap, which is serving to provide selective passage, limiting the upstream dispersal of non-native channel catfish while physically trapping razorback suckers and other native fish, moving them upstream. Investigations into this bypass channel indicated that few razorback suckers were actually moving into the trap, and once again, it was unclear if they were using upstream habitats following passage. To assess movements of razorback suckers following translocation, we began by physically capturing fish below each barrier when we thought the highest densities of razorback suckers would be present. So generally before, to catch razorback suckers at the waterfall, we used graft mount electrofishing in early March and in early April at the PNM Weir. As individuals were captured, we recorded all relevant length, weight, and other biological data and transported them approximately 2 to 4 kilometers upstream where they're released upstream of each barrier. To assess specific movements following translocation, we implanted between 40 and 48 of our translocated Razorback Suckers with these internal coil antenna coated radio transmitters beginning in 2020. Each of these radio transmitters has a battery life of about 300 days, and they do produce a mortality indicator if movement has not been detected for up to 24 hours. So beginning in 2020, 41 Razorbacks were implanted with these at the waterfall. Known Razorback Suckers were implanted with transmitters at the P&M Weir due to access restrictions from the COVID-19 pandemic. And then in 2021, we implanted 48 new transmitters below the waterfall, translocating those fish upstream as well, and another 40 upstream of the P&M Weir in 2021. To assess specific movements at each barrier, we use these solar-powered, continuously operating remote radio receivers, each of these being equipped with a bidirectional Yazzie antenna. These were used to detect the exact timing and direction as translocated fish were likely to move back downstream to a barrier. In addition to having one located at either the waterfall and the P&M Weir, we deployed 6 additional remote radio receivers throughout the river at these important transition zones. We then assessed specific movements upstream using mobile river-wide telemetry surveys. These primarily consisted of either raft-mounted or aircraft-mounted radio receivers, as well as a few hiking and biking surveys when needed. We generally surveyed downstream using the highest recorded signal strength paired with the GPS data to record individual locations within 100 meters. We then used these data to calculate individual residency time above each barrier following translocation. We quantified upstream movements using a total linear range. We then delineated specific putative spawning aggregations by limiting that total linear range to only including detections within the spawning season, and limiting those detections further to only include the core 50% within that distribution curve. This essentially allowed us to indicate where Razorback Suckers were spending most of their time within the spawning season, limiting those long distance movements it might take to reach a spawning site, while still allowing for the possibility that they could visit multiple spawning sites within the spawning season. So getting into some of our results, we've plotted here the proportion of individuals that have been translocated still remaining upstream of a barrier following that translocation date. So we see at the Paiute Farms waterfall in 2020, more than 80% of our translocated fish remained upstream for at least 3 to 4 weeks within the spawning season, after which they began a downstream movement back downstream to the barrier. We plotted here the orange line, which indicates the mean river temperature, and as well as the blue dotted line, which indicates the mean discharge on a given day to help indicate the environmental conditions and to help delineate when we might expect that spawning season to occur. So we did have a period of about 37 days where that remote receiver malfunctioned at the waterfall, but we generally expect that downstream dispersal to occur at a similar rate. Once again, we were able to delineate when we expect that spawning season using mean water temperature, which is indicated by that red box. As we see here, once again, the majority of our fish remained upstream for about half the expected spawning season and then began to move immediately back downstream to the waterfall. We saw a similar movement pattern at the waterfall in 2021, where once again, more than 80% of our translocated Razorback Suckers remained upstream for about 3 weeks, and once again began that downstream movement, taking them below the waterfall down into the Lake Powell inflow area. Saw somewhat different movement dynamics, over at the P&M Weir in 2021. Here we saw more than 60% of our translocated Razorback Suckers remained upstream within the entirety of the spawning season, so not just a proportion. So in general, fish translocated above the P&M Weir tended to stay upstream for a longer period, but still at some point we're likely to move downstream of the barrier at about within half a year at least. So where did they go in the meantime? We were able to delineate our total linear ranges and indicate that these translocated fish were likely to continue their upstream movements. However, we generally saw a more bimodal distribution from translocated fish at the waterfall, and they tended to move much longer distances, where we had several individuals that were moving up to 260 kilometers upstream the barrier, as well as many individuals that only traveled between about 5 and 10 kilometers. At the P&M Weir, these movements were somewhat more uniformly distributed and generally seemed to be restricted between about 1 kilometer to about 20 kilometers upstream that barrier. This was somewhat reflected when we went to delineate these specific aggregation sites. As we see here, we did detect 4 aggregations above either barrier. However, in general, these aggregations were further upstream away from the Paiute Farms waterfall, and in general, they were a little bit closer to the P&M weir. So we'll take a little bit closer look at each of these aggregations in relation to the barrier, beginning with the waterfall. We detected our first aggregations upstream about 3 to 5 kilometers, and this was somewhat surprising, where we detected 14 individuals using this area in the spawning season, since generally this area has been inundated by Lake Powell, so the substrates are generally shifting sand and silt. We did not expect to find suitable spawning substrate in this area, but upon closer look, it seemed that enough of the lateral washes were discharging loose cobbles and gravels that might serve as suitable spawning substrate. Further upstream at the Slickhorn Canyon, these aggregations were not surprising to us, where we saw the majority of our fish using that area. We expected this to be the nearest available sort of riffle habitat type with those spawning substrates for Razorback Suckers. Once again, the other surrounding areas within the lower canyon reaches are impacted by Lake Powell full pool level. So this is really the first available sort of riffle habitat type in that area. Further upstream at the P&M weir, once again, we saw these aggregations generally somewhat closer to the weir itself, between about 3 kilometers to about 15 kilometers. And we generally saw these aggregations more uniformly distributed throughout these aggregations. We generally expect that to be tied to the resource itself, being the spawning substrate. Downstream below the waterfall, in those canyon reaches, we expect the resource to be more patchy and not very evenly distributed, whereas upstream of the P&M weir, we see a much higher density of those riffle habitat types and potentially a higher availability of loose cobbles and gravels that might serve as spawning substrate for these fish. So to sum this up, we supported our predictions that in general, translocated fish were likely to stay upstream of either barrier. And we detected several upstream movements where they were detected into these putative spawning aggregations. And we expected that the timing of these detections within this expected spawning season in aggregations was indicative of spawning behavior. Furthermore, these results combined with mark recapture data at either barrier leaves us with evidence that about 2,000 endangered razorback suckers are annually affected by either of these barriers. And we did provide a strategy where we were able to improve access between spawning sites and potentially allow an increase in reproductive output. Furthermore, we provide evidence of multiple movement strategies that should be addressed in recovery criteria. Particularly, previous research showed that these razorback suckers that are moving to the Paiute Farms waterfall are spending the majority of the year in Lake Powell, thereby exhibiting more of an adfluvial life history where they're moving into more of a riverine habitat to spawn and moving back downstream to the lake. Compare that to the fish that are translocated at the P&M weir, which are generally moving shorter distances, but still moving between habitats and need access to these spawning sites and need open connectivity between those barriers. I'm sorry I'm not there to present this live, but feel free to email me with any questions. And thank you all